Today's topic is going to be around the UCS-X series. The UCS-X series is a newer architecture from the current UCS platform. Some changes have happened over the years. Cisco's been selling compute now for almost 12 or 13 years underneath the plate. And as the technology evolved, as power and cooling requirements evolved, Cisco had to develop a newer chassis for the newer requirements, specifically around power and cooling. So let's get into it. So we're going to cover the hardware components. We're going to look at the system chassis. We're going to look at the fabric, the compute options that are available, some storage options that are there, as well as networking and data flow, and then of course, power and cooling conversation here. The architecture of UCS-X series is almost identical to the current UCS domains that our customers are familiar with today. The chassis, still has on the back of it what we call fabric modules, or in the 5108 chassis, we call them IOM modules. But basically, in the back of the chassis, you have the fabric modules. The fabric modules connect up into the chassis, into the fabric interconnect. We utilize the same fabric interconnects that customers have been purchasing. It's the 4th gen fabric interconnect. And then that kind of goes up into the top of rack switches for networking, as well as for fiber channel communications. As you may notice on the middle, the green links and the blue links, they're now 25 gig native. So some evolution has changed with regards to a 10 gig architecture in the current 5108 to now a flexible architecture in the X series. And I'll discuss what I mean by flexible in a couple of minutes here. So kind of diving into the chassis, as we kind of look at it at the chassis level, one of the main differences in the new X series 9508 is that its servers now go in vertically, right? So if you kind of look at this picture, we still have 8 slots. The servers kind of go vertically into the enclosure, and the chassis itself is 7 rack units instead of the 6 rack units. So it's 1 additional rack unit from a size perspective. On the back of the chassis, we have the intelligent fabric modules, the 9108. The intelligent fabric modules are similar to the IOMs. They basically provide network connectivity out of the chassis up into the fabric interconnect. But also on the back of the chassis on the bottom, there's actually something brand new. This is the UCS-X Fabric module. The X Fabric module is going to be able to connect slots together on top of the PCIe bus. So something brand new inside of the chassis with no additional cables or connections. We'll be able to connect and merge multiple slots together through the PCIe bus. As well as when newer enhancements come out, like the CXL technology as well. The chassis is actually powered with 2 additional power supplies. So for max power capabilities inside this enclosure, we have 6 power supplies. The power supplies are actually now 2,800 watts, so a little bit more than the current ones in the 5108, which is 2,500 watts. We enhanced the power distribution. It's now 54 volts, so more efficient. And we also provided enhanced fan modules as well inside of the system. The chassis does support grid redundancy and +1 and +2, as well as N for power. Most customers will utilize 4 power supplies, because you may not need the max power currently. But, we typically like to sell them with 6, so you could have enough as we kind of, go forward in the future. One of the main things that this chassis has is that there is no more mid-plane, right? If you're familiar with the 5108 chassis, you actually had a mid-plane. That mid-plane actually had wire traces for the I/O connectivity. One of the challenges with the 5108 chassis with that mid-plane is that the mid-plane was really locked at 10 gigs. Now, when we sold this chassis, 12 years ago, everybody's like, wow, I don't really need 10 gigs. I was only at 1 gig. Today, people look at the 10 gigs and says, why do I need 10 gigs, when now there's 25 gig and 100 gig capability? So in the new 9508 chassis, we eliminated the midplane to provide greater flexibility with inside of the I/O connectivity point of view. This prevents technology lock-in inside of the chassis, inside the enclosure, and provides extremely efficiency, with regards to the airflow, power, but also configure as you need for additional workloads in the future. So if you're familiar with Cisco's Nexus product line, the Nexus product line has been doing mid-planeless architecture for a long time. The UCS team with this new enclosure basically adopted a similar philosophy. So basically now the intelligent fabric modules that go in horizontally in the back of the chassis will connect directly to each slot or to each server, creating that logical, fabric concept. So when we kind of look at this, capability, today, the fabric module is 25 gigs. The next fabric module could be 100 gigs. The one after that could be 400 gigs, right? There is no midplane that, that has any type of blockage. The capability also has the same thing when we look at the bottom of the chassis, right? The bottom of the chassis has this new X fabric capability. So this is now a chassis that has a dual fabric architecture. The top is for the connectivity to the network. The bottom is the connectivity to the X fabric, which is basically the PCIe extension and the CXL technology extension coming in the future. There could actually be other things down the road. That's the beauty of this mid-plane architecture. So if we kind of dive into the actual fabric adapters themselves, the compute node is independent of the fabric technology, right? The compute nodes themselves are servers, the motherboards, but how we actually get the connectivity to the fabric is through a connector, right? The connector is similar to the VIC cards that everybody's familiar with from the UCS server architecture. We're currently utilizing the 4th gen VIC cards. If you're familiar with UCS, we sell the same 4th gen VIC cards on the B200 servers, the B200 M5s, the B200 M6s. We even have the same VIC card on our rack mounts. So it's just a different form factor in here. That connector for the adapter is what physically connects into the fabric module. So if we kind of look at the key differences between the two, right? Nothing is changing with regards to the 5108. The 5108 chassis is not currently end of sale. We still have customers purchasing them, but we kind of brought it into the next generation for the next decade with regards to what the 9508 kind of has to offer. Some of the key differences, as I called out, but in this chart, I'll kind of reiterate some of them, is still has 8 slots, but it's 7 rack units. The power supplies kind of went to 2,800 watts versus the 2,500 watts. You could have 6 of them in there. So in essence, instead of a 10 kilowatt chassis, you now have almost a 17 kilowatt chassis at full population. The power distribution internally, 54 watts, so more efficient than the older 12 volt distribution. I meant 54 volts versus watts, right? But it's from the wattage from a distribution standpoint. From the fans perspective, the fans are 100 millimeters as well as 40 millimeters, depending upon which ones we look at. But overall fan cooling power, what they kind of call CFMs, we actually have almost double at 1,000 CFMs for the chassis. Now, from the networking point of view, right, because we don't have any mid-plane, currently today with the current IFMs that we have to offer, we could actually bring in 200 gigs of performance or bandwidth to an individual server. And then we also have the connectivity, northbound as well as the connectivity southbound from a connectivity. The chassis is also designed to be future ready for when liquid cooling comes out in the data center. Currently today, air cooling is is what people are utilizing. You know, even tomorrow, air cooling is what people are utilizing. The big push for water cooled or liquid cooled type of architecture, predominantly in the 2023 timeframe, is when the GPUs kind of go into the 500 watt range and 600 watt range, and then also into the 700 watt range from a GPU standpoint. The same power requirements will also be there for the CPUs. Currently today, we have CPUs in our servers that are 265 watts, you know, from a CPU perspective. You know, not yet at the 3, 4, 500 range, but 400 watt and 300 watt CPUs are definitely on the horizon. So regular air-cooled systems may or may not be able to provide the system from a cooling perspective, but this enclosure has the designs and the capabilities up front and the certifications to actually support both a closed loop as well as an open loop cooling systems, both from the chassis level as well as from an individual server level as well. So these are the things that we're thinking about with this enclosure for the next decade from a technology perspective, right? Keep in mind, you know, when we were selling servers, you know, at the beginning, you know, when the M1 servers came out, the CPUs were probably only around 150 watts, right? Today, most of my customers are purchasing servers around 205 watts. Some of them are getting them into 235 watt range. So definitely from that power and cooling point of view, this is one of the reasons why we had to think about a new enclosure. So the next piece is kind of looking at it from the fabric layer. You know, as I mentioned before, this is still a UCS domain. We still have the fabric architecture that has to be connected into it, right? We're still utilizing the same 6400 fabric interconnect. It is the 4th generation. There's 2 form factors. There's a 1U and a 2U version, all depending upon port density requirements. There's nothing different besides port density requirements. This supports both the current 5108 chassis as well as the new X Series chassis as well through the IFMs, the 9108s, 25 gig. It supports the 4th gen VIC cards. For the X Series specifically, it started with the support on the 4.2.1 train. So the 4.2.1 is when the X Series kind of came out in the release track. And from the port density, it still is the same ports because it's physically the 4th gen VIC, 4th gen fabric interconnect. Now, one thing that's different that I kind of want to make sure that everybody's clear on this is that even though that this is the 4th gen fabric interconnect, the X Series brought to the table a new way to manage it. And this is now being managed through Intersight only. Now, you may say, well, how could it be Intersight only if I'm utilizing the same fabric interconnect? These fabric interconnects now have the capability to support what I call a dual management operating system. The fabric interconnects can support the traditional UCS managed mode or Intersight managed mode. So in order to support the X Series, the fabric interconnects need to be in a Intersight managed mode. Think about the fabric interconnect in the same paradigm as like a Nexus switch for the data center, like a Nexus 93.108, you know, as an example, right? Or 93.180 as an example. Those Nexus switches supports a dual operating system as well. It supports NXOS mode or ACI mode. That's the same logic of what we have done with the fabric interconnects. If you know a little bit about the fabric interconnects, they are actually Nexus switches underneath the cover, just rebuilt and re-architectured slightly for UCS domains. So that's really an important part, and depending upon time at the end, I'm also going to be showing a demo of Intersight management mode with a UCS architecture. So, looking a little bit underneath the covers, right? We have the intelligent fabric modules, and you may say, why don't you just still call them IOMs or IO modules of what was in the 5108 chassis, right? We changed the name of them to be intelligent fabric modules because potentially in the future we may add more intelligence to it, right? So that's the reason why we kind of changed the name to be an intelligent fabric module versus just a IOM or a IO module. There is an ASIC on here, similar to the the previous ones as well. There is the logic of what's actually happening inside the fabric modules. The fabric modules also has internal fans to kind of keep that quadrant of the chassis cooled, right? Because if you notice in the back of the chassis, the fan modules were just in the middle. On the top and the bottom, you have the fabric modules and you have the X fabric. Those fans on those modules do the cooling for that quadrant of the chassis. These are all 25 gig based today. 5th gens are actually around the corner. So 5th gen architecture is coming out and it's going to be 100 gig based. But on the 4th gen that we have here with the 9108 25 gig, we have 25 gigs northbound and we have 25 gigs southbound. Every slot still gets 4 lanes or 4 connections or 4, pipes, how you kind of look at it, for a total of 100 gigs, per server. And then as we look at it, and that's 100 gigs per server per side, right? So this is just one fabric module. And then we have the external connections that kind of go north. Now looking at the compute side of the house, right? So this is based upon the M6 motherboard design, right? So when we kind of look at it from a motherboard architecture, the M's from Cisco stands for motherboard design. This is the M6. It's based upon the 3rd generation scalable Xenons from Intel. We still have the VIC on the back connectivity standpoint. The left side of the blade kind of goes into the fabric module. The right side of the blade kind of goes down to the X fabric modules. We can utilize both adapters on the back of the server for bandwidth connectivity. So that's where we could get either a single VIC through the MLOM or an additional VIC through the mezzanine adapter, which is optional. And then on the front of the server is, where we have the drive carrier, right? So the same way that the M5 servers had a modular drive carrier, we have a modular drive carrier in the M6 servers here as well for the X series. There's a couple different iterations for the drive carrier. We have a standard hardware RAID controller. We also have pass-through controllers, and then we also have M.2 drives as well. So from a drive option perspective, it could be a SAS SATA, from a drive perspective. All SSDs today or NVMEs. There is no spinning drives, for the X series is all based on SSD, NVMe technology now. And then from a memory perspective, since this is based upon the 3rd generation scalable Xenon, it does support 16 channels going into the CPU. So that's where these servers now have 32 DIMM slots on them. We also support persistent memory with Intel Octane memory for persistence, storage on the actual memory bus. So from a comparison standpoint, we do currently today have a B200 M6 for the 5108 chassis, and we also have a M6 motherboard design for the X series architecture. From a CPU, from a memory, they're the same, right? It's the same server, same amount of DIMMs, same CPUs. The difference here is that on the X series, we actually have more drive bays on them because we went vertically. And, from a slot perspective, we're able to have 6 hot swappable SAS drives or NVMe drives on the front, where on the M6, you could only have 2 slots, right, from a storage perspective. And with the M6, because there's only 2 slots, you can only do RAID 0 or RAID 1. On the X Series M6, because we have 6 drive bays, we could actually have the full array of RAID support from, RAID 0, 1, 5, 6, from a RAID capacity standpoint. The VIC card is a different VIC because it's now 25 gig based, still based on the 4th gen ASIC, but it's now 25 gig based. And instead of giving 80 gigs of bandwidth to a slot on the X series with this generation of VICs, we could actually bring in 200 gigs of bandwidth per slot. The X series is only supported with the 6400 and newer, or when they get released, fabric interconnects. So from a storage standpoint, right? So if we kind of look at it from a storage layer, right? The storage options that are on these servers are flexible now. There's the carrier that kind of goes in the front, and the carrier that goes in the front can be either a RAID controller carrier. And from a RAID controller carrier, we have the capability to either have 4 SAS SATA NVMEs plus 2 additional ones if you want to put some NVMe only in there, or 4, right? So flexible from that standpoint. We also have a pass-through controller, so it's not a RAID, but the drives are directly attached to the PCIe bus from a pass-through controller standpoint. That's typically used for NVMe because NVMe, you want direct access to the CPU versus having NVMe, being limited and going through a hardware RAID controller. And then, of course, if you don't have any drives, we do put a front blinking panel on them as an option. So from a drive standpoint, you can have multiple combinations of drives, either SAS SATA or NVMe. You could have all SAS SATAs, or you could have all NVMEs. The all NVMe one is a different mezzanine adapter, so you just have to plan that ahead if you want to go with the all NVMe versus some of them with SAS SATA SSDs on them. Now, one of the other things that have changed recently is in the past, previous servers, or even dating back for many evolutions from a boot media standpoint, we used to work with compact flash. We used to work with USBs. Then it went to SD cards, or SD flash. Well, the newer technology for the boot media is actually now utilizing M.2 drives. Now, M.2 drives is the new standard, should I say, for boot operating systems. They're not hot swappable because they're actually internal on the actual motherboard. So that's one downside. The plus is that they're relatively cheaper to it, has a much higher endurance than SD cards. And if you have been following like VMware, they've been doing a lot more I/O on their boot media drives. So they actually are starting to move away from SD flash. So we do have M.2 hardware RAID modules on the motherboard. They do support up to 2. Typically, the size is like 240 gigs or 960 gigs from a size standpoint. So the next piece is kind of looking at it from the network and the data flow. When customers kind of look at the servers, they kind of like saying, hey, what is the connectivity? How much bandwidth am I going to get? What is the capabilities, with regards to the actual, VIC card? The Cisco VIC, the virtual interface card, is extremely flexible. Even, going back, to version 1 of what we had to offer, we could carve up logical vNICs, virtual NICs, or logical virtual HBAs into the hundreds if you choose to. So from a theoretical perspective, you could go up into 256 virtual interface cards, right? Interfaces. Most customers are probably around the 10 range. They may carve up 2 vNICs for vMotion, or 2 vNICs for the data, 2 vNICs for the iSCSI traffic, 2 vNICs for the kernel traffic, and things like that. And then they also may carve up a couple of VHBAs for fiber channel connectivity. So a lot of flexibility in here, newer offloading hardware capabilities as well, like VXLANs and NVGRE, Geneve offload, but also, lower latency, for NICs as well, with regards to the VIC architecture. So as a comparison, right, as I mentioned, you could actually have a server that has a single VIC card, or you could have a server that actually has a dual VIC card, right? In the same way on like a B200 server, you had the VIC 1440 and the VIC 1480. You could even have it on here as well with regards to the capability. What that delivers to the server is additional lanes of traffic. The lanes of traffic in here are all 25 gig based. And the way that the architecture is, the way that the VNICs are, a single VNIC can have up to 50 gigs of traffic. But from an aggregate point of view, we could have an aggregate of 200 gigs, going into a single server. And the main thing to kind of look at is really the aggregate, right? You're not really looking at, providing that much single-threaded performance. From a single-threaded performance, you do get to 25 gigs. To get additional traffic, you just aggregate multiple VNICs together to get additional, traffic flows. We have similar block diagrams that people are familiar with in the block diagrams in the B200 class. This is now the block diagram architecture in the X Series class. Same basic functionality. We have 2 lanes kind of going into each of the slots, either the MLOMs or the mezzanines. If you do have the capability to utilize both mezzanines and the MLOM, we actually bridge it together across the VIC bridge. And that's how we could kind of move the lanes. Because remember, the fabric modules are connected on the top of the chassis. So all the lanes from the fabric module have to come in on the top, and the top is where the MLOM is. So to be able to get the lanes onto the mezzanine adapter, which is on the bottom of the slot, we have the bridge that kind of maps internally the traces down to the bottom, which is different than in the B200 class and the 5108 chassis, because that had a mid-plane design, right? The mid-plane design, there was only one fabric. In here on the X series, there's a dual fabric architecture. So all the IO comes in the top and the X fabric kind of comes in on the bottom. So kind of, something to kind of think about with regards to the connectivity. What does the operating system see? So from an operating system perspective on the B200 class, they store 20 gigs going into the NICs. On the X series, you now have 50 gigs, coming into the NICs. So this is the X series M6 with the VIC 14425. And this actually shows that you have more aggregate bandwidth going into the actual physical adapters on the operating system level. Just some eye charts. These slides are going to be available, for distribution, I believe, at the end to the TAP team here. And when we kind of look at it from a performance, like pay show me, right? So from a X series perspective, you could get 50 gigs aggregate per VNICs. You could get 25 gigs per VNIC as well for a single flow. And then when you kind of look at it for a per VNIC, it's 50 gigs that are presented to the operating system as well. So the numbers are there with regards to the performance and with regards to what we're advertising up to the operating system. And then from a throughput standpoint, right, this is a server with the VIC 14425 and 2 VNICs configured. One VNIC configured for Fabric A, one VNIC configured for Fabric B. It's an active data plane. So from here, we actually show an aggregate throughput of 100 gigs on both VNICs. And then with the same server, but just by adding an additional VIC card, you could actually get now additional aggregate bandwidth, right? So now with the X210, with the VIC 14425, plus the VIC 14825 in the mezzanine adapter, we carve up 2 VNICs on the VIC, 2 VNICs on the mezzanine VIC, and we have, both the A side and the B side going from an active perspective, and you could actually see an aggregate bandwidth now of 200 gigs going into a single server. So extremely powerful with regards to the I/O. Once again, customers may tell me, hey, I don't need this today. And I'm like, that's great. The system will provide you now for the next couple of years, of where people are going with regards to the bandwidth capability. Also keep in mind that you're not locked to just this bandwidth either. As newer fabrics get developed, the 5th gens are, coming, later on. The 5th gens will bring 100 gig of bandwidth leaving the chassis. Today, the bandwidth leaving the chassis is based upon 25 gig. So the last piece of the puzzle is the power and cooling, right? A lot of customers have said to me, I never had a problem with power in my 5108 chassis. And they said, that's great. We never want you having a problem with power in the 5108 chassis. So when we look at it from a power and cooling perspective, we're at a point that if you fully populate a 5108 chassis with all M6 servers, the B200 M6 servers, depending upon the CPUs that you pick, depending upon how many DIMMs you put on each server, if you max out the B200 M6 in the 5108 chassis with grid redundancy for the power distribution, you won't have enough power, right? So that's where the power calculator is kind of coming into play. The numbers kind of fall around 6 servers, in a fully maxed B200 M6 enclosure. So that's where we now gave the customers the option to either go with the M6 design in the 5108 chassis, or you could have the M6 design in the X Series enclosure. So the M6 is basically your tangent, right? Do I want to continue with the architecture in the 5108, or do I want to continue with the architecture in the new, X Series? One of the things to kind of keep in mind is that when the M7s come out, the M7s will be supported in the 9508 X Series chassis. So if we kind of look at it from a power cooling perspective, we have enhanced the data collection inside of the enclosure. The temperatures, sensors, the fan speeds, there's temperature sensors throughout the entire enclosure, from a sensor point of view. With regards to the temperature sensors that are all over the enclosure, if you kind of look at a single server, there's temperature sensors on the DIMMs, right? There's temperature sensors on the intake. There's temperature sensors on the drives. There's temperature sensors on the outtake and also on the mezzanine adapters. So depending upon where the temperature sensors are reading, is it hot on the top, hot on the bottom, is it cooler one place or another? We're actually now doing zone-based cooling inside this enclosure. So depending upon where certain components are hotter versus others, right? You may have an enclosure and you may only have two or three slots populated. Well, if that's the case, I could actually control the fans on that side of the chassis versus the other side of the chassis. Why is this important? Is because as the fans turn, they generate and they require power, right? If the fans aren't turning as fast, we could actually now save power inside of the system as well. So zone-based cooling inside this enclosure, very, very important, very, very critical, as well as improved power distribution. As I mentioned, the power distribution now is utilizing 2,800 watts. They're titanium rated. We do have the capabilities to support low voltage as well as high voltage. I would say 99% of my customers are utilizing the 208 or the higher voltage from a power. And that gives you your 2,800 watts approximately per power supply. Same type of connectors on here, the same C19, C20s, typically what people utilize within the data center. And then, one of the things that we typically haven't used that much in the past on UCS, because typically on the 5108 chassis prior to M5s, there wasn't really a need that customers cared about power calculators, right? Because we always sold 4 power supplies. We always utilized all 4. When M6s kind of came out with the 5108, we really had to use the power calculator to make sure that we could fully support that chassis from a power standpoint. But the power calculator is also available for the X Series. The X Series now has more power than you really need on a day-to-day basis. So you could also utilize the power calculator to know if you need to power up all 6 power supplies. You may want to purchase all 6 power supplies and just not power them up, or you could just power them up and they could do load sharing across the grid as well. But the power calculator is extremely useful. It does provide BTU calculations for the HVAC teams or the physical plant teams, as well as, you know, average draw, maximum draw, peak draw, you know, coming from the system. So with that, from a slide perspective, that's really what I had to present. I'm doing the lab instance from the dCloud environment. If anybody's familiar with Cisco dCloud, dCloud is a great tool to do demos and labs for customers. One of the great things about dCloud is that it's time-based. Well, that could be good or bad. The other good thing about it is that it's a stable state type of environment. So hopefully it's always, you know, up and running and, you know, providing a consistent view. The reason why I'm also using dCloud is that the X Series is relatively new. The X Series came out in last June. But of course, with the whole supply chain delays, I don't have any from my personal lab. So I'm utilizing the dCloud environment to kind of illustrate some of those capabilities now. I just brought it up. We're inside of Intersight. So before I kind of go into and kind of show what Intersight is, you know, just a high level here, you know, the goal today is not to kind of do a Intersight deep dive, but more on the X Series. As I mentioned, Intersight is a requirement for UCS-X Series. Now, Intersight is also used for Cisco's entire compute platform. So if you have 5108 chassis, if you have rack mount servers, if you have HyperFlex servers, if you want to build out a Kubernetes environment, we have Kubernetes services inside of Intersight. If you want to do orchestration, we have orchestration capabilities. We also even have workload optimization functionality. So we could actually optimize virtual infrastructure like virtual machines, right-size them. We could also right-size cloud workloads for AWS and Azure as well. So one of the things that Intersight is, it's a platform that we're building additional features and functionalities on top of it. From a UCS Manager point of view, right? Customers have UCS Manager that they've been using inside of their Blade servers, you know, today. That UCS Manager instance lives inside of the Fabric Interconnect, right? So all the policy management for the UCS domain was inside, self-contained in a single Fabric Interconnect pair. If you had 2 Fabric Interconnect pairs, right, 2 UCS domains in UCS managed mode, then the policies aren't shared between the multiple domains. So as customers built out multiple domains, every instance was separate. So what Intersight did in the Intersight managed mode of configuration is that we moved that policy engine off of the Fabric Interconnect and now up into Intersight. Now, Intersight itself can be deployed in 3 modes. It can be deployed in a SaaS model, which hopefully most customers will adopt because it's easy from an adoption standpoint. The SaaS portal is there. All you have to do is just claim your servers. We then have the capability for a connected virtual appliance, which is now Intersight lives on-prem, or your data lake is on-prem in that virtual machine. You own the responsibility of maintaining that virtual machine. And then we have the connected experience, so you still have the connected TAC, right? And from a connected TAC standpoint, we could do proactive RMAs, we could push out security alerts, security announcements that affect your infrastructure. We could also push out field notices. We could do hardware compatibility checks and things like that. So that's where you get the connected. And then the third deployment model for Intersight is a private virtual appliance, which is quote unquote air gap. So absolutely no connectivity to the internet. You lose that connected experience. So there's pluses and minuses based upon how you want to utilize the Intersight deployment. 95% of my customers utilize SaaS. And then the other 5% is utilizing the connected virtual appliance. I don't have anybody utilizing the air gap. But if you have an environment like the DoD, the Fed, where they have a true air gap environment, then the private appliance will fit those needs. So from a high level standpoint, this is a Intersight infrastructure that's actually modeling a single UCS domain, utilizing the X series behind it. And if you notice here, there's a couple of things that kind of, bring out that I could actually see that I have 5 servers. All the servers are, a blade architecture. I could see what version of the firmware that I'm running on the blades on the right-hand side. I could also take a look and see if they're assigned. Now, what do I mean by assigned, right? Remember, when you did UCS Manager on-prem, inside the Fabric Interconnects, you could build service profiles. Inside of Intersight, we're building server profiles, right? So here, I have 9 server profiles that are defined, and I have 5 that are actually deployed, right? So that's why it says okay, they're okay and deployed. And they're running on the X210C as the server. So they're running on the X series. There's also other widgets that you could create. This is a widget for a specific server. This specific server says that it's actually running what server profile it is and what version of code it's running and what the status is. So let's dive into it from the high level, from the physical standpoint. I could look at the Fabric Interconnects, right? Remember, this is a UCS domain, so there's 2 Fabric Interconnects that build a pair. The Fabric Interconnects here, if I drill down into them, you could actually see what models they are. You could actually take a look at the ports and see what the port configurations are on them. If you notice at the top, there's additional stuff up here, right? You can see the inventory, which is, perfect, right? You assume that you could actually see the inventory of them. But also, you could also take a look at the domain profile for them. We're building the profiles for these endpoints with Intersight, and Intersight is pushing out the policies for the configurations on these endpoints. So this is a Fabric Interconnect. This Fabric Interconnect has a port policy. And if I click on this port policy, it will actually bring up the port policy for me of this Fabric Interconnect. It will tell you the role of this port, what type it is. And then if I scroll down, I see that port 1 and port 2 is assigned as a server Ethernet. Hence, these are actually color-coded, right? So it actually says over here as well. And then all the other ones on here on the right, from a policy standpoint, are unconfigured. If I want to change the role of a port, I don't go into UCS Manager anymore. I go into Intersight and I modify this port policy for one specific port that I want to choose, right? I have read-only access into this instance, so I can't actually physically change something. But all you have to do is just go in here under Actions. It will say, modify the port profile. The same thing here, I could also look at my VLAN assignments, right? The VLAN assignments here are also being done with the policy. So this is a policy that I actually have. And what's nice about these policies is that I could use them on multiple domains as well within my organization to be consistent, not just within one domain, but now I could actually have global consistency across multiple domains if they all share similar policies, right? If they don't share similar policies, then you have to have 2 different policies. But in here, if I have a policy for VLAN 10, VLAN 11, VLAN 12, and VLAN 1096, I could utilize the same policy and share them across multiple Fabric domains. So the great thing about Intersight is that it's not specific to a single domain anymore, but it's specific to your entire organization from a globally consistent policies and rules. So here I also have my QoS policies. I have my NTP policies as well that you could actually set. So in here, the NTP policy is called UCS-WS NTP policy 01. And I could actually see that I have a single, NTP server. This same policy could be used on multiple instances that you have. If I go back to port policies, you can actually see that I have Fabric Interconnect A, Fabric Interconnect B. Now, under a connection standpoint, from a connectivity, I could actually see that this Fabric Interconnect is actually connected to 5 servers underneath the covers. You could actually see that one server is actually disconnected. It hasn't been able to pull and reach Intersight for some reason. And I could actually see that this pair of Fabric Interconnects is actually connected to a single chassis, right? So the same way that we had the model inside of UCS Manager, we're now modeling everything inside of Intersight from a configuration standpoint. If I click on this chassis, you'll notice that I changed to the chassis view now on the left. And I now have all my chassis, the 5 that were in there. You could actually notice that I have 4 power supplies in this chassis. 2 of them actually have blinking panels. So if you hover over them, they say empty, but visually we changed them to be a different graphic. And then I could also look at the inventory on these servers as well, and look at the IOM modules, look at the fabric modules, which there isn't any fabric modules. I could look at the fan modules the same way that you do in the connectivity, as well as the connection state. Right, the connection state here would be the connectivity up to the Fabric Interconnect. And then I could also look at the servers themselves. So from the server standpoint, I have the physical servers. One of the things that you may notice here on the servers is that I have the physical servers in the first column. I have the health, the contract status, the IPs, the model numbers here. But this column domain will tell you where this server is connected into what UCS domain. And then because all of these servers are connected with a server profile, you could actually see the server profile here. And these are all hyperlinked. So for example, if I click on this server profile, you'll notice that I'm now underneath the tree of configure, underneath profiles. I can see that this is the server profile. It came from a template right over here on the left-hand side. In the same way that you get all the same representation from UCS Managed Mode, we're not utilizing here. The great capability, once again, just to reiterate, is that I could utilize my templates and assign it to a server profile in any domain within my organization, not just one entity. And then, of course, you could actually see what the policies are that are assigned to this profile. So this is where we get the closed loop and configuration point of view for the entire system here. Another thing in the last couple of minutes here, Intersight is fully API driven. You could utilize APIs to communicate to Intersight. You could utilize Terraform and create infrastructure as code and communicate to Intersight. So the API is open. There's GitHub repositories for configurations. So fully flexible, either configuring it by a mouse, right? Or creating code to actually do the configurations for you. So the flexibility is there with regards to how you want to actually utilize the system. So I know that we're almost at the top of the hour. I'm going to pass it back over to Mike to see if there's any final questions or comments. If not, I appreciate everybody's time today.
No, thank you. That was awesome, Eric. I appreciate you walking through that demonstration on the vCloud. No, there are no questions in chat. So with that, thanks everyone for joining today. Have a fantastic weekend. And like we mentioned at the beginning of the call, we'll be posting this demo and the presentation to our YouTube channel. We'll get that sent out shortly. Thanks again, everyone.
Thank you.